Welcome to the Analytics Power Hour. Analytics topics covered conversationally and sometimes with explicit language.
Hi, everyone. Welcome to the Analytics Power Hour. This is episode number 269. I'm Tim Wilson from Facts and Feelings, and confession time. I am mad about MAD. And by MAD, of course, the latter one in that statement, I mean the acronym MAD, which stands for Median Absolute Deviation. I came across that technique, I think 8 or 9 years ago. I actually needed to go look in GitHub to figure out my timestamp on that. When I needed to be able to detect likely outliers in hundreds of very small data sets, just 10 or so data points each. It's a long story, it's not important. But median absolute deviation is one of many, many techniques for detecting outliers, and outliers are the subject of today's episode. With that in mind, we're operating very much within one standard deviation of our mean host count, and that I'm joined by 2 co-hosts for this episode. Julie Hoyer from Further, do you have a secret favorite outlier detection technique?
No, I don't. Maybe I will after today.
Right down the middle. Okay. It's unhealthy, my mad affection, but we'll get into that. And
but very reasonable. It's an excellent choice. Yes.
Awesome.
Validation.
Okay, now I'm validated and we're done.
Yeah, that's the whole show's over.
And Val Kroll from Facts and Feelings, do you try to just operate pretty close to the mean as a matter of course?
Oh yeah, you know me.
Nope. There was definitely not a conversation about how cold water needs to be in order for it to be drinkable right before we started this recording. So we're going to be chatting about some different outlier detection techniques. Shout out to our listener survey last year that asked that we dip our toes into specific techniques and methods here and there. But we're also going to get a little more philosophical, perhaps about when and where and how outlier and anomaly detection are useful. For that discussion, we needed a guest. The perfect guest would be someone who devoted so much time and thought to the subject that they'd written an entire book about it. But that'd be crazy. I mean, such a person would surely be an outlier themselves. Oh, wait, what? What's that? Oh, our producer is telling me we found such an outlier. That was the voice you've already heard. Brett Kennedy is a freelance data scientist, and he's the author of a book, Outlier Detection in Python, which is 17 chapters of outlier goodness. And I'm not just saying that because median absolute deviation, MAD, gets introduced and described in chapter 2. Today, Brett is our guest, so welcome to the show.
Well, thank you very much.
All right. So maybe a good place to start is with how you came to write an entire book about outliers. I think I had a good sense that there are multiple different techniques depending on the nature of the underlying data and kind of what the question at hand is. But what sparked you to think, hey, there's a whole book's worth of material here and I should be the one to write it?
Yeah, well, there definitely is a whole book's worth of material there. There are a lot of techniques that can be used to identify outliers, and they all have different nuances to them. There's a lot of kind of gotchas with outlier detection. How it started in my end is I was working for a company, and we were building software that was performing outlier detection. The software we were building was to be used by financial auditors. So the idea is someone who's performing a financial audit on their clients, they would go through their clients' data, which include their bookkeeping records, as well as we had code in there where they can check text documents, contracts and invoices, meeting minutes, and the like. And we introduced outlier detection for those as well. But we started with the bookkeeping data. And so what often happens when auditors perform a financial audit is they'll get a set of transactions in the bookkeeping records, or sales, purchases, payroll records, and the like. And there often be millions or hundreds of millions or billions of these records. So it's not really feasible to manually check them. So what can be done in that case is just to randomly check, spot check them. Or you can use outlier detection to try and find the ones that are the most unusual in there, with the idea that those are at least among the most relevant records to check. Auditors would also want to check the ones that have large financial values and those other kind of criteria as well. But the ones that are the most unusual can be kind of the most likely to suggest either errors or fraud or working outside of the normal controls and situations like that. So when we were writing the software, it's kind of a different experience when you're writing software that's going to be given to other users that where they can be encountering just any sort of data, who knows what, and we won't be there to be able to update the software as it's needed or work them through the issues. So we had to make software that's very robust going out the door that can handle basically any situation and can provide meaningful explanations to what's being found. So we were doing that, and at the same time we were also working with regulators around the world. So the regulators are organizations, most countries have them, that regulate how financial auditors work, how they perform financial audits. And they were interested in looking at this kind of new wave of technology that companies like ours were creating, and things like outlier detection. And they were raising a lot of important questions, like, well, a couple in particular. One was, when your software flags an outlier for an auditor, how's the auditor going to know why it's unusual? It'll just say, look, this sales transaction is statistically unusual. Okay, why? And also, a point they were making was, if the software flags a bunch of transactions as unusual, with a little bit of effort, you can go through those and say, okay, these are not statistically unusual. These are not interesting. They do suggest fraud or errors or circumventing controls or something. But how can we check the converse? How can we check all the 99% of the transactions that weren't flagged? How do I know there weren't transactions in those that were even more unusual or more important to flag? And those were a couple really good questions, and I think that really got myself and the team, thinking deeply about interpretability and testability and outlier detection. And we got into some areas that I think, there really weren't other people doing much. I mean, I went through a lot of academic papers, I think like 200 or something, just to try and figure out what the state of the art. Now, I should say, outlier detection literature is kind of a lot easier to read than a lot of other areas of computer science.
Well, that's interesting.
Yeah, that was my experience, anyways. Now, maybe that was an artifact of, once you've read the first 100 or something, they get
second 100 are a breeze.
Yeah, they don't seem as bad as. I mean, they're a little shorter and a little more manageable than say deep learning or some other fields which are awesome, often manageable. But yeah, so I went through a lot of the literature and kind of came up with a good sense of where the state of the art was. But also we were doing some kind of original research in terms of making outlier detection interpretable, explainable, and doing work around testing these things, which is actually a difficult problem. I mean, it's solvable, but it is a difficult problem.
Picture this: you're stuck in the data slow lane. You're wrestling with broken data pipelines, manual fixes. Suddenly, streaking across the sky, faster than a streaming table, more powerful than a SQL database, able to move massive data volumes in a single bound. It's not a bird, it's not a plane, it's Fivetran. I need a hero for data integration. Fivetran, with over 700 pre-built, fully managed connectors, seamlessly syncs your data from every source to any major destination. No heroics required on your part. That means no more data pipeline downtime, no more frantic calls to your engineers, no more waiting weeks to access critical insights. And it's secure, it's reliable, it's incredibly easy to deploy. Fivetran is the tool you need for the sensitive and mission-critical data your business depends on. So get ready to fly past those data bottlenecks and go learn more at fivetran.com/APH. Unleash your data superpowers. Again, fivetran.com/APH. outliers.com/APH. Check it out.
So to me, kind of the nature of, and I had a question when I was kind of starting to scan through parts of the book as to what the difference is between an outlier and an anomaly. And the book, you said, I think that you kind of use them interchangeably, which I was like, cool. This is an easier thing to read than I would have thought if there was some. So maybe that backs up your point. But it seems like the concept of an outlier is one of those where, if you know data deeply and you look at it, you'd say, oh, well, that's clearly an outlier. Like it's one of those. It's this kind of nebulous idea, and the question is, well, and the brain may be with certain types of data be able to kind of look at it or sense it or say, well, that temperature reading of, the peak temperature was 150 degrees centigrade or Fahrenheit, either one, clearly is an outlier. That's just logic. But is that like a fair way, as you work through different techniques, it's kind of like what would have a human logical interpretation of, well, that's out of the norm and something we'd call an outlier, but it's not like it's a definitionally precise line. I mean, it kind of can't be, right?
No, and it's not. And no, that's one of the challenges of outlier detection is that there's really no definitive definition of an outlier. And one of the consequences of that is, there's a lot of different ways to try and find outliers. Like you mentioned, median absolute deviation. That's one. I go through, I don't know, like a couple dozen others. And there's a reason there are so many outlier detection techniques. It's just there is no. If there were, we would just have one outlier detection algorithm, and that would be it. It would just say for sure these things are statistically unusual and these things are not. And what makes it difficult as well is there's kind of a difference between what's statistically unusual and what's useful or what's interesting. So like with the example I just gave with going through financial data, you can find things that are statistically unusual, but there's nothing noteworthy about them. They just don't occur that often. I think, like in the book, I gave the example of annual payments. So some companies will have these payments they'll make once a year. So they're unusual because there's only one per year, but there's nothing otherwise interesting about them.
Can I actually just call out something about that quote? Because I actually love that. That was one of the things that I pulled out, that it's about when you're looking at those transactions, that some of those annual payments, because they are once a year, that they're not problematic, but they're understood by the analyst. And so I thought that was really interesting, because when I think of like outliers and all this detection, I think of a lot of things that are happening not always with human touch or human touch considered first, like the analyst role in all of that. And so it just really struck me as like an interesting concept that it's that there's processes and, different methodologies, but that it really does take the interpretation to really kind of even say whether or not it is an outlier, because there's no definition. And I was like, I had never thought about that before. I thought that was super interesting. Yeah,
there's still a very important role for an analyst in all this. And financial data is a little more straightforward than some. If you get into a lot of scientific data and we get into other domains too, like get into like image data or video, audio, and so on. It can really require an analyst to take a look at that, to say, okay, this is something we're interested in pursuing further, or this is not. Now, depending on the domain, somewhere that might be even a little bit more straightforward than financial data would be where you have sensors to monitor industrial processes. I mean, that's something that's another application of outlier detection. And, it's if you have a certain like assembly line or something like this, it could be, well understood what the normal behavior of the system is. And really anything outside of that is probably worth looking at. But even there, like, you can have certain things that are statistically unusual that are just known to not be of interest. Mm-hmm. But they can reoccur. So you might need an analyst to look at that and say, okay, if this specific combination of sensor readings over this time window occurs, this is known to be of interest, or this is known to not be of interest. So the analyst may only have to look at it once, and going forward, the system may be able to say, okay, this is of high importance or mid importance, so we'll send out alerts, but we won't shut down the system, or it's known to be a non-issue, then it can do.
When you were rereading the credit card fraud detection, it reminded me one time when my fraud alert went off on my credit card because those were purchased made in the suburbs.
Okay.
And that credit card company knew, was like, that's not right. She doesn't go out to the suburbs. And I remember be like, no, that was me. It was an accident though. So be sure to flag this again in the future.
Yeah.
Something has gone wrong.
Yeah. I think a lot of us that can remember too, like credit, the fraud detection in credit card is now, it's not perfect. It's a very hard problem, but it works so much better than it did, say 20 or 30 years. Like it used to be something like that. Even people that did go to the suburbs routinely, it would still just shut down the card. It's if it had seen it before. Yeah, so it's a little bit smarter. They're a lot smarter now, but it's a very, very difficult problem because there's a lot of kind of subtle ways people can if they have a stolen card or something, can go about committing credit card fraud.
Yeah. So going back a little bit to the methodologies, because you said, you were able to write about a lot of them. It's not just like a handful, 3 or 5, there's over 10, it sounds like, at least, of methods. So when you, in past scenarios or in general, when you're trying to decide which method to use, what are you using to help you make that choice? Are you looking at attributes of the data? Does it have more to do with the business context of the data? Or is it even, I'm thinking is it the use of the actual outlier once it's detected? So is an outlier bad and you want to remove it? Is it good and you want to understand why it happened? Is it, or it's is there a big issue with a false positive of an outlier? How sensitive is the scenario to that? I'm just wondering, what goes into helping you consider and choose your method?
Right. Yeah, well, just to take at the very end, just quickly there's definitely a concept of false positive and false negatives. Type 1, type 2 errors with outlier detection. You can over flag things or under flag them, and interpretability is very, very important. It's usually much more important than in other areas of machine learning. Like if you're creating a predictive model or say a generative model where it's just trying to, if you have a model you want to say produce a picture or produce a sound clip. You don't necessarily, if you're debugging it because you're the person developing it, you would need to know why it did what it did. But if you're a user, you don't really need to know, why it generated what it did, or if it's making a prediction about something. You don't. In some contexts you do, in some you don't, but you often don't need to know exactly why. But it's very, very common in outlier detection to need to know why it flagged something. It gave something a higher outlier scores and something else a low outlier score. And that can really come into your choice for which detectors you use, partially because, unfortunately, very few of them are interpretable. They tend to be black boxes, which, and you can imagine a scenario, if you're using outlier detection for, if you're investigating fraud or security, or you're looking for criminal activity or something like this, or even if it's just you get an outlier detection has flagged something that says, your industrial system is behaving unusually, you should shut it down. Well, you need to know why, so you can investigate that quickly. And if there's a security threat or a safety threat or something like that, you want to be able to investigate it quickly and efficiently. And unfortunately, most outlier detectors don't let you do that. So that can certainly affect your choice. Some are a lot faster than others, or slower, and some do detect different types of outliers, like median absolute deviation, for example, is an excellent detector, but it's intended to detect extreme values in numeric data, which means it won't detect outliers in categorical data, or date or text data. Mm-hmm. It won't find internal outliers, which means values that are kind of in the middle but unusual. They're not extremely large or extremely small.
Well, so I think I think back to early in my analyst career, once I was trying to get the team to not look at and this was with digital marketing data, so it was time series data, and I didn't want, like, it was never going to move in a perfect line. And I was struggling with getting told every single week or every month, yes, the number was going to go up or down, and trying to figure out, had it gone up or down enough,
an unusual
to be
amount,
an unusual amount. And I do remember at the time, like, it's like I was trying to, like, rediscover discover statistics from the beginning. Like, it was a well-intentioned but horribly executed exercise where I would take the data and I would calculate the mean, and then I'd do, like, little plus or minus one. I think I did, like, a best fit line, like a regression, and then I put plus or minus on either side of that line a standard deviation. Horrible, because the data was always trending, but it was time series non-stationary data, and I was calculating the mean, which was kind of dumb because
if it's moving, it's not a constant mean. Yeah.
Yeah. So I mean, that was one
dumb.
where
Confirmed.
Yeah. I mean, it was definitely
trying to be
it served the. I mean,
It's funny.
It served the purpose in that it gave me the ability to put, like, a band around it. It was horrible. It just gave something, and people sort of believe that, it needs to go outside this range. But I think that's when I discovered, like, I was trying to use Z-score with, like, 10 data points, and it's like, well, it's going to be like that's where I wound up finding MAD, because that was one that it's generally a little bit better when you say I have a small data set. So I guess, So
that's, I think, a good piece of Julie's question as well, is some detectors are just better suited when you have large amounts, very, very large amounts of data. They're just very efficient, and some are not, and some handle smaller data sets as well. And
I think a lot of the, like, talking about all the patterns, like when you do talk about time series, that you have data moving along and then there's, like, a step function or a rupture and it changes, like, you call out, that's different from, like, a spike or an extreme dip, and it's different if the data is kind of trending. So it seems like you need to understand the nature of the data that you're looking for outliers in, and that narrows down the techniques that might be appropriate. Is that?
Yeah. If you're looking at within time series data, I mean, part of your I guess the answer to your question, Julie, is it depends on the type of data, like you were suggesting. So if you're dealing with image data or video or audio data, there's certain tools that are basically, if you're dealing with that type of data, it's got to be a deep learning based technique. That's likely the only thing that's going to work. And with text, you might want to use deep learning or a base method or a simpler method. With tabular data, there's certain techniques, and with time series data, there's certain techniques. And it comes down a bit to some of these issues, like performance and what's going to tend to balance your false positive and false negatives well. But it's also like what type of outliers you're interested in, because maybe if it spikes a lot, that's not interesting. It just once in a while to do that, and yes, it's statistically unusual, but it's not something you would investigate. But maybe in other scenarios, if you get a spike, you don't want to look at that. But if you get a whole bunch of spikes within a short time period, you might want to look at that. Or sometimes you can actually, what the opposite could be interesting if it's unusually flat over a period of time, or unusually smooth, straight line, which might suggest, it depends on the situation, could suggest, like, just a sensor failure. Like if it's not particularly sensitive, so it's just giving a flat line, like a flat. Yeah.
Mm-hmm. I was gonna say, is that an example of what you were saying of an outlier hiding in the middle? Like, it wasn't an extreme high or extreme low, but contextually, if we're monitoring a sensor, it would be unusual that it was flat and in the middle for a while. Is that a good example of that one? Because I was like, whoa, an outlier in the middle, like...
Yeah. It's actually,
they're everywhere.
Yeah, yes. Well, that's one of the things about outlier detection is, depending on how you look at your data, you can... If you look at, and again, that's why there's so many outlier detectors, because if you just look at your data one way, you'll miss other ways in which it's unusual. Well, I'll get what I was getting at before with inlier detections. I give maybe a simpler example of that is, say you just have a list of sales records for a company, And, generally most of their sales are around $10, or you sell some items that are $10. And you also sell items that are $100. So a sale for $60 is kind of in the middle. It's kind of weird. So it'd be an internal outlier. So yeah, you can get where you have kind of bimodal or multimodal distributions. You can get things. Okay. You can get values in just a numeric series that are unusual, even though they're not extremely large or extremely small. And you get something that's kind of a similar-ish issue with time series, where it's I guess the same thing where over time, maybe your temperature, if you have or say you have a sensor that reads sound volume, and maybe the volume tends to be either very low, like 0, meaning machinery's off, or it's high, machinery's on. If it gives you a reading in the middle, kind of halfway in the middle, well, if that occurs rarely, then that would be unusual. But it's not an extreme value. It's the opposite. It's an internal outlier. It's called. Yeah.
Okay. So we've been talking about a lot of these outliers that are indicators of something going wrong, but I also want to talk, because this is something that it makes sense, but again, like seeing it framed the way you put it in the book was helpful, about that it's not always necessarily looking for problems. Like I think about financial markets are looking for dislocations so that, people can move money and take advantage of that, right? Or like there's an audience that's being underserved, if it's a marketing example. Yep. And so now we can think about offerings for them. So I guess just curious about the balance of those concepts, ideas, and how they potentially work differently with the type of approach that you think about for identifying them and the processes that lead up to it, and then happen because of it.
Yeah. I mean, that's one of the key points about outlier detection is, so anything that's unusual is not necessarily a problem, depending on the context. I mean, again, if you look at like an industrial system, then probably anything that's unusual, odds are it is a problem, because the normal functioning is also the optimal function. There's machinery can't spontaneously behave better than normal, but a financial market or marketing, you can get. And in science, I mean, a lot of what's done is just looking for the anomalies, because they're what's scientifically interesting. So if you have a collection of records about instances of a certain animal species, if you find something that are or plant species or something like that. If you find instances that are anomalous and it's correct, it's not a data artifact, then that kind of can expand your sense of what's possible, or maybe trigger some research where you're trying to figure, well, how did that come about? It's used a lot in astronomy, for example, as well, because that's one of the fields of science where we're just accumulating monstrous quantities of data, and it's just well beyond possible for a person to go through all the images every day. And even if you could, there's just so much in some of the images coming back from astronomy. So if we're looking for a kind of new phenomenon or phenomenon that we have seen before, but only rarely, then just running outlier detection on the images coming back from the telescopes can be a very effective way to find something. Ideally new, but at least rare.
Do you have a favorite? Coming back a little bit to the time series thing, because I think that's what we work with at least the most.
Yep.
For time series data, which is mostly numerical, like you said, what are some of your favorite methods, maybe based on interpretability? I just feel like when we have run into outlier detection that's maybe built into certain analytics tools that we work with, there's no interpretability. So you keep talking about based on interpretability. So I'm interested.
Yeah.
Which ones out there help us do that? Which ones have the best? What are your favorites?
Can I
sure.
Can I throw in, just because Julie and I both have worked with a Bayesian structural time series. Black box is to me the magic of exactly how all that works, but conceptually having a forecasting technique, having a forecasting engine of some sort that then says based on the data up to this point, we would expect the future data points to be X or Y, and if they're outside of that range, like that I actually feel like is interpretable. Not that somebody needs to understand that this is how this whole winter's forecasting or something worked, but I'll just throw that in that is background that at least actually I think Val's sort of seen us mess around with that too. But like that the forecasting is one mechanism of outlier detection, but what else is there?
Oh, well, just as Julius, you were asking that, in my mind, I was thinking the forecasting based ways. It's probably my generally
look at that.
Now some of the other methods are simpler than forecasting based, and therefore might be a little bit more interpretable. But I think I agree with you, Tim, that like if you make a forecast and you say like we predicted on Thursday that we would have $2,000 in sales, and we actually had $16,000 or so. That's well outside of what was predicted, and you can see it's clearly an outlier. It's not completely interpretable necessarily because, well, why did it predict 2,000? Now, it could be that if you look at your history and you see, well, here's the general trend and here's the seasonal patterns and the other information it took into consideration. It could be that a prediction of 2,000 is pretty straightforward, so you can see why. I think in general, time series data lends itself to interpretability a little better than a lot of other types of data, just because it lends itself to plotting better than other types of data. And but I mean, with looking for outliers in time series data, you can go. Well, the simplest extreme method is just looking for extreme values. Just looking, you're basically just ignoring the sequential nature of the data. You're just ignoring the time component entirely, and just looking at for very, very large, very, very small values. That's the simplest. And if you plot that, it's really easy to see why something is extreme. Like if you get
but if you don't plot it and you actually did have, if the data was like on a trending upward, then it would tell you that your outliers were at the start of the period and the end of the period because they were the lowest and the highest, right? And that's
if you can you do risk that, and that method can be a little bit overly simplistic. That's why I am kind of leaning. I do kind of like yourself lean towards the forecast method for outlier detection. But
is that one where like, and we had a recent episode about linear regression. We did not talk about like ARIMA, but is ARIMA like the base level sort of forecasting that's like, or does ARIMA fit? I'm trying to bucket them in my head.
Yeah, I think when you think really talk about outlier detection with time series data using a forecasting method, I mean you can use any forecasting method. So ARIMA methods would be common, or exponential smoothing, but you can use recurrent neural nets or really anything that's able to project into the future. Even standard machine learning techniques like random forests and XGBoost and CatBoost and so on can be used for time series prediction. That they have some limitations in that if we have the situation you just described where you have a strong upward trend and the future values are going to be generally a little bit larger than anything that's occurred in the past, those types of models can struggle to make good predictions in that situation. But if you have a time series that's fairly stable over time, if there's not an upward or downward trend, they can work well. And in that situation, just looking for extreme values can be one way to find a certain type of outlier. Now, we'll miss other outliers, where more contextual outliers where you have like a spike or something where you have a value that's like, say you're looking at daily sales figures or something like that. You might have a value that's normal, but not for that time of year or that day of the week or something like that. It's just different, or it's just different than the values that have occurred recently. So it's still an outlier in that sense, but it's not an outlier in the sense of being unusual, over the last year or something. Yeah.
And what's interesting too, the technique that Tim brought up, I was just thinking like the context behind that, or what makes it interpretable, is that you're choosing your pre and post period based on like what's changing in the environment. So you have that knowledge going in, assuming that, right, everything else is held constant enough over the period that you're isolating the mechanism that would cause an outlier. You're hoping, in whichever positive direction, an improvement. So it's interesting, though, is like the interpretability comes from that, again, context of the situation and you choosing these parameters to then apply it.
But if you were monitoring something, why wouldn't you say that I'm going to keep rerunning it and it's always going to use the data up through yesterday or through a week ago? And then, like, I don't have a planned intervention. I'm just going to, I guess I have to have an assumption that there are any outliers that occurred before last Saturday aren't going to muck the model up so much that
which
it couldn't
they can
detect.
Yeah.
Okay. So that's the risk. That's the issue.
Yeah, there is a risk. Yeah, I mean, that's actually one purpose for doing outlier detection on time series data is even if you're not interested in delving into those outliers, just removing them because they can outliers in your time series will affect your sense of what's normal, which can preclude your ability to really find outliers. And so,
but then if you remove too many outliers and then use that to build your forecast, then
it's a balancing
you're going
act.
to keep finding. Oh,
yeah,
wow, okay.
Yeah. But you can imagine, like, say you train your model on 1 day's worth of data in order to see if there's any outliers the next day. But the day you train it on is Christmas or Black Friday or something.
Right.
That's an anomalous day. So, or it's just a day when your computer system went down for a bit. So if you use that, it's it's a really good point you make, because this is one of the tricks of outlier detection is what do you use to define normal, and sometimes what's normal can be different than what's desirable. So. No, I gotta say, like an industrial system, often they're fairly close to the same thing. But if you're looking at marketing data or, something like this, there can be distinction, and it's with outlier detection. It's always compared to what. So this can be. So if you have a day where I don't know, like say you're monitoring, you say you have a web site you're monitoring and you're making sales on the website, maybe you're getting a lot of sales that day, and you're looking, well, is that anomalous? Well, compared to what? So you can look at the last day or the last week or the last month, the last year, and all of these can be kind of useful to compare to, but also misleading to compare to, right? So I think my tendency, for what it's worth, is to have kind of multiple frames of reference when you're looking at outliers. So you say, okay, the sales we've had the last hour, that's unusual compared to yesterday, but it's normal compared to, say it's Tuesday, last Tuesday. Or it's unusual compared to this day of the year last year. And you say, okay, well, and then you have a little bit more context it gives you kind of sense. Like if it's unusual in all those senses, then you say, okay, this is more unusual.
It does, and this kind of goes back to where you were starting with trying to build sort of a generally repurposable outlier detection into kind of the financial world. In the digital marketing world, every platform has at least once, if not twice, come out with hey, here's a way to just intelligent alerts, which is basically like, we're going to do anomaly detection at scale on the behavior on your website.
Sure.
And those have comically failed, like the naivete coming out of the product, because they find things like, sales have tanked in California, and in this part of California, and it's right when there are wildfires in California where everything's shut down.
Yeah.
Or they really find things that really are kind of legitimate noise, because it's like trying to figure out that threshold. Or there's Adobe Analytics had this where you could set your threshold for what you wanted to monitor, and it was basically giving you the technique was something that you'd set a 95% or 99% threshold, and the idea was this was going to just kind of magically tell the analyst where to go look for stuff, but it always the calibration of not having it say it's identifying outliers every day, in which case you're overwhelmed and can't track them down, or it's like so rarely to finding outliers that there's some suspicion that stuff is being missed. Like as you're describing it, it seems like it's so much more about you have to kind of think through call it the process. It doesn't have to be manufacturing or sale. I mean, it can be, what are these things that you're looking in? What is the nature of that underlying data? What is it you can impact? What is it you truly care about, and what can you impact? And then what is the right technique, and what's the right way to do it? I don't know. Maybe I'm mounting my rant. So there were just times when each one of those rolled out, they'd say the analyst job just got easier, which I actually think AI, there's some thinking of that too, that point the AI at the data and it will tell you, it will give you insights. And it's like, well, it's just it's going to find outliers, but without the context or
the intelligently. I think what you're just saying is kind of bring me back to your first question is, why did I want to write the book on this? And partly because that is such a difficult problem. I mean, I don't think it's unsolvable, but it is a very difficult problem. And that's, we were kind of in that situation at the time too, where you're trying to make something that's like, if you're making software for your own company and you're writing it and you're using it, and it's a simpler process because you can just constantly tweak it until eventually it gets better over time. When you're making software and having to send it out, you kind of have to go through all that process ahead of time. You got to do a lot of thinking of what can go wrong here, and it's exactly what you're saying. A lot of over reporting and a lot of under reporting, a lot of where it's not under reporting, but you don't really know that because you can't. It's hard to determine. Yeah, I mean, these are tricky problems, and this is so. What I was finding too is just going through the literature on outlier detection is almost all of it was just talking about how outlier detectors work, and there's a lot of discussion, I guess, as well around how to combine multiple outlier detectors, how to set thresholds on the scores that they're producing, and things like that. So these sort of technical issues that are very, very important, and I cover those in the book too. I mean, they are important. But what was always being left out of the discussion is just what you're talking about now. Like, how do you actually maintain an outlier detection system that gives you the outliers you want without giving you a whole ton of other ones? And I think fortunately, realistically, when you first set up the system, it's just going to flag anything that's statistically unusual for whatever reason. You need a way to kind of tune it over time. And there are ways to do that, and some of these things aren't necessarily bad. Like, I mean, when there was wildfires in California, probably certain things were down, and they were legitimately outliers. It'd be kind of weird if it didn't flag that. But the point you're making is it just generates all kinds of noise, right? It just gives you things that are unusual in ways that are not pertinent to you. And there is a little bit of the process involved with just. Well, a lot of it comes down to categorizing the outliers that it's producing. So it says, okay, if it finds this type of thing, I know I'm interested. And if it finds this sort of thing, I know I'm not interested. And if it finds anything else, then I haven't seen that before. I want to investigate and determine that. And then, over time, you can kind of tune the system to find what you want more than what you don't want. And part of that's like, comes down to a question you asked before, is like just choosing the detectors you use. You may, as you get going, realize, well, I'm not actually that interested in extreme values. In some contexts you are, but maybe in some contexts or maybe you specifically are interested in extreme values. But it's flagging a lot of things that are unusual combinations of values, which I'm not interested in. So you might want to downplay those outlier detectors unless they find something super extreme. Don't bother me. Just tell me about or maybe not. Maybe you're not interested in very small values, only very large values. So you can do some filtering on the output of the outlier detection. But it's also a lot of comes down to like tuning it, tweaking it to to put the emphasis on the sort of things that that you are most interested in. And a lot of things, what happens too with projects is, when people start, over time they change their mind. Partly because, if something was interesting, it legitimately was interesting, but just no longer is. At this point, it's understood. And so you see, okay, I'm glad it flagged it for a while, but not in the future. Or it starts flagging things that, geez, I never thought of that. It's the unknown unknowns that can really be interesting and important. So you don't want to dampen down what it's producing too much, because sometimes those are the most important ones, even though they can be outliers among the outliers that are flagged. So
levels.
How much of an outlier? Yeah. So you can actually, and I'm not being facetious, you can actually run outlier detection on the results of your outlier detection, and that can be quite legit. Because say you have a case where you're just analyzing millions of documents or millions of table rows or something like that. Like if say you have 1 billion transactions that come through because you're a credit card company or something, even if you're only flagging 0.01% of the transactions, that's still a lot, and which means it's still beyond probably the ability of a person to go through them. So you really, you probably at first need someone to go through just to see what you're dealing with, but over time you want to kind of reduce that workload. So when if it's just kind of flagging the same thing over and over and over again, because it truly is statistically unusual. It only occurs once every 10 billion rows, but by the time you've gone through 1 trillion rows, it's like over and over and over.
So Mo isn't here, but I have a scenario.
Mm-hmm. Yay!
I have to, one of our other co-hosts. So
Okay.
this unearthed, honestly, preparing for the show, unearthed so many memories unlocked for me. But I used to be in market research, and we used to do different types of, like, it was called a conjoint study or conjoint analysis. And basically it was like understanding which features and attributes and combinations of those things were most attractive, like at what price point. So there was a study that was commissioned by US Cellular, RIP. They didn't go out of business because of this study, I swear. But we did this study for them to understand what features should they consider and what combination to make for the next smartphone and what price point should they potentially sell them at. And we discovered through a couple of those analyses that there was this group of people who were not sensitive, that there was just no combination that would make this an attractive offering. Turns out through some secondary analysis that they were Apple loyal. And this is 10 years ago, before people were as divided as they are today.
Okay.
But we decided that we were going to remove those outliers, air quotes. So I don't know if this was A, the right thing to do, or B, the right labels for it. So I'm just interested in your reaction. We removed them, but in future times we ran this study, we would ask, do you currently have an iPhone, and how much do you like it? And if they did and they liked it, we would just remove that. We didn't even, thank you for participating, here's your $10 Starbucks gift card.
Sure.
No longer interested in because they didn't behave like everyone else who was sensitive to the addition or subtraction of features at different price points. But I'm just curious about your take. First of all, were those actually outliers? I honestly don't know how you would define them. And just the application of that in the context of that business purpose.
Yeah. They might be outliers or not, just depending on, again, there's no real great definition of that, but if they're rare in your data, then now are they rare in society? Well, or were they? And if you go back to the this 1970s or something, that was probably pretty rare. But
Val has never owned an Apple product in her life, so she
true.
considers Apple as outliers. She's like, yeah, freaks, and we're like,
Okay.
no, it's a pretty sizable part of the population.
Well, that's the thing. There's kind of a statistical sense of normal, and there's the platonic sense of normal. So you can argue you can argue that no matter how statistically normal they become, they're still. You can argue that. Wherever you wish, you can argue that, I guess. Yeah, when you're doing that kind of research, and another example that comes up in my line of work is with creating predictive models, which is the same sort of idea as, you train your model on a certain type of data, and then once you put it into production, if it's encountering data that's unlike the data that it was trained on, it's not going to know how to behave, and it's just going to basically be behaving kind of half randomly. And so it could be in a situation like you're describing. You can do market research on a certain cohort of the population that has certain properties, and then then if you try and market, create a marketing campaign to people who are just different than the people that you looked at, they're just their ages are unusual, or their country they live in, or the language they speak, or in any way that might be relevant. If it's different than the group that you did your market research on, it's going to be hard to extrapolate your findings. That you're extrapolating your findings is going to be a little bit suspect. Yeah, so it can be a useful exercise to do.
So were we wrong when we called them outliers?
Well,
again, context, Tim. This was like 15 years ago. I was a baby analyst, so it wasn't as prevalent.
I'll go with a statistical definition and say that depends on how many of them there were. It sounds like there weren't too many. So I'm going to say if that's true, then yes, they were statistical outliers in that sense. But one of the things that's important too is like everybody is statistically unusual in some sense. Like if you look at us in enough different ways, we're all odd. And there's have you ever heard of what's called the myth of the average? Yeah. So, and I think if you had, so did you hear about it through the studies the U.S.? Oh, well, this okay. Oh. The U.S. Air Force studies where they're looking at fitting cockpits to their pilots, and so they looked at the average leg length, the average arm length, the average torso width, and I forget how many dimensions they measured everybody in. But what they found was that pilots were the pilots were all generally average in most of these dimensions, but there was no single pilot in the entire U.S. Air Force that was normal in every single dimension. And that's just looking at our physical dimensions. If you start introducing hundreds of ways to look at people, do they like Apple versus whatever Android or whatever.
The group that shall not be named.
There could be people that are just diehard fans of some I'm sure there's still BlackBerry fans out there. Well, I'll be 100% there's still, because there's one, there's nothing wrong with it, and two, there's very few people buy them. So there's definitely the people you're looking at doing market research, you can always define as being unusual with respect to the product you're trying to sell in some
totally.
regard. Yeah.
Mm-hmm. I mean, look at car manufacturers, right? The whole Invisible Women, all women were outliers removed from the data set for the crash test.
Design,
right?
Yes.
Like that was
yes.
On that front, I think that was probably, treating them as outliers to be removed might not have been the way to go.
Yes. Yeah.
Well, on that note, we didn't get into Z-score or modified Z-score or so many other techniques that maybe would be a little actual tough to get too deep into. So I will, before we move into last calls, I will, plug the Outlier Detection in Python book. Again, it is very readable, has both the code examples and the explanations and visualizing of the data sets. So if you're interested in more on this topic, then cannot recommend that book highly enough. But before we go, we like to do a last call and go around, have everyone share a link or a thought or a post or a book or a movie or a outlier, something that stuck out to them as being interesting. And Brett, you're our guest. Would you like to go first?
Sure. One of my interests, as well as outlier detection, is interpretability. So I think I talked a bit about how interpretability is important for outlier detection. There's not nearly enough research in that field, but I'm interested in interpretability in general, and and explainability as well. And one of the techniques for that is SHAP, which relates to feature importances. So
Julie just perked up. What?
Yep.
We just talked about this at work. It was very timely that you said that.
Oh, okay. Yeah, I've been interested in SHAP values for many years, and permutation importances as well. I I do read a lot of articles on Medium, and one that caught my eye a little while ago is by a writer named, I think, Samuel Mazzanti, I believe. It's called "Your Features Are Important. It doesn't mean they're good." And it's just I thought it was a really nice article that kind of explained how shop values tell you what features your model is using, but they're not telling you what features it should be using. So the features you're using are contributing to your model predictions, but they're also contributing, some of them, to your model error. There's actually a set of articles on Medium talking about that sort of thing, and talking about how you can use SHAP for feature selection and combining it with permutation importances, get a kind of better sense of what your model is doing and why.
Nice.
I'll have to
Julie,
check
can
that
you
out.
share what your what the nature of the discussion you were having about SHAP values was?
Yeah, we one of my coworkers, he actually got asked by a client, their data science team ran a model, and they got all this output with a bunch of SHAP charts, and it comes from Shapley, right?
Yep.
And Tim, I thought you and I and Ben had a whole conversation about Shapley charts, but that's what this SHAP was. And he had a ton of the charts, and it was kind of crazy. It was like he was then asked to make the model output in this 25-page readout, technical readout, more interpretable for the data scientists to take to their stakeholders. So we were kind of talking about like, well, what matters here? And we were getting down into like per location, that the model was trying to predict locations for customers.
Okay.
And it was interesting because you had a SHAP chart for each outcome of the model. And so then we got into the discussion of like, all these features look different per location outcome. But I think what's most important is like, you just want to know, can you trust of these features available? Do you trust your model? Is it accurate enough to then use it to predict these outcomes? And then you can go market based on these predictions. So it was kind of like, let's take a step back. But we got like really deep into the SHAP charts before we got there.
Yeah. You can go extremely deep into. There's a lot of nuances with them.
Yeah.
Wow.
And the
So
big
do you have
question
a
of, that you said, like, do you have the right features listed? Like, you could have a bunch of crap features and have a SHAP like graph for it, but it's like, it doesn't really matter if they're crappy features, but it won't tell you that.
No, it won't tell you that. No, it won't. But yeah, no, that's the thing. I think they're very, very useful charts, but I think sometimes they're made to be something that they're not. They're
Definitely.
Yeah. Wow. Well, Julie, do you have a last call to top your...
I do, but I'm glad I
Use of
got to
SHAP
comment on SHAP because my last call is not anything close to that.
No.
Start with an SH too? Yeah.
No, actually. A CH. So my last call is just something that has brought me joy, and it has an AI feature in it that now I'm thinking maybe uses outlier detection. So this app is Chatbooks. It's just an easy way as a busy mom, parent to like keep some memory books printed and like coming monthly. And it has a feature though that I really like using, which is like select my best 30 photos from the previous month to like get my book started. And then I can edit from there. And I always wonder, like, how does it choose? Some months it's like spot on. Some months it's, like giving me not screenshots, but like random photos that I'm like, I don't need this printed. So
I think a good question. I mean, would
I don't
the
know.
pictures you'd want, would they be the most typical for the month, or would they be the most atypical?
Ooh, right. And that's what I'm wondering. I'm like, it's got to be based off the mix of photos I had for the month, right? And maybe some months it's very clear that I was like at an event and it's choosing like the clearest photo from like a run of similar photos or something.
Yeah, if I wrote it, that's what I'd be tempted to do. But is that really the best?
Yeah. So the technology part of it had me wondering, because I'm just interested, like, how are they doing it? And seeing as a user, like, do I find this feature actually useful or not? But in general, like, I've just really enjoyed that app and getting the photo books, and it's fun.
Good.
Nice.
I like it.
And Val, what's your last call?
We might have to edit this because there's a word that I can't say in the title and the subtitle. Okay, you ready? And I know the word, I just can't pronounce it. Our human habit of anthropomorphizing everything.
Yeah.
Should we be anthropomorphizing AI? I can't
Oh no,
say that word.
Okay.
I practiced this 5 minutes straight before I had Google say it out loud to me before I joined this recording, and my mouth can't make the motions. Anyways.
Not an issue. I 100% know what you mean.
Okay, so we all know what I'm talking about. So this was also a Medium article published by Doc, written by Daley Wilhelm, and I thought it would be interesting because, like, we all know about the, should we be nice to generative AI or like the interfaceless AI saying like thank you or please. But as I was reading this, I saw so many more examples that I hadn't even thought of, which just makes it a really interesting read. So even saying like the AI listens or learns is doing that versus saying the AI is designed to or it's built to. If you say that it sees this or it looks for this, it's actually detecting or finding patterns. And I'm like, it's so like it runs so deep. But anyways, it talks about some of the problems with doing that it actually changes the way people expect what the output is in terms of like accuracy or the role that it can play. So anyways, it's just kind of like a thought piece, but I really enjoyed that. And so hopefully you all can practice saying that word with me. Anthropomorphizing.
Does it talk about the different ones that they'll say thinking like while they're like that's the weighting is a okay.
Yeah. I think they encourage us thinking of them as kind of human terms because it's how they communicate with us. They do say like I'm thinking about this or I'm looking at that or
And I'm someone who anthropomorphizes everything. And like I've done this for years. Like I remember trying to explain to my roommate why our DVDs needed to be in alphabetical order in the case. And she's like, why? And I was like, because that's how they like to be. And she's like, you need some sort of exotic pharmaceuticals to chill out because DVDs can be in every order you want. Anyways, but it's an interesting read. All right, Tim, how about you?
Well, I guess I'm going to go with a streak of Medium posts because this one
I like it.
Has been out for a while, and it's one but it's a post called "Optimizing at the Edge Using Regression Discontinuity Designs to Power Decision Making," and it's just it's kind of coming out of Instacart, kind of the tech team at Instacart, like kind of publishing how they do it, but it's a good explanation. Like regression discontinuity is one of those things that like Joe Sutherland would reference as being a technique, but I hadn't found something that gave a sort of a good, simple explanation of like, what is it? How does it work? So it just kind of falls in that whole little pot of like, oh, here's another kind of technique that in the hands of a more skilled individual. I mean, for me, it'd be running with scissors to actually try to do it. But I mean, it came through my feed and I kind of read it and kind of got into it. I was like, oh, that's cool. For a brief moment, I understand what that's actually doing. So
those are always good moments when you're like, oh, I think I get it. And then, 10 minutes later, you're like, I don't know if it's
well, then I made a note of it.
I shouldn't have closed that tab yet.
I'm going to use this for a last call in a few weeks. And now as I'm using it for a last call, I'm like, I hope nobody asked me to totally explain.
Yeah, Brett,
guess I got to read my own last call again. Damn it. All right. Well, this has been a fun chat and super informative. Like I think we've definitely proven this is a broad and deep topic. So Brett, thanks so much for coming on and joining us for this.
Awesome.
Thank you very much for having me. That was very nice.
Cool. No show would be complete without thanking our producer, Josh Crowhurst, who should probably also call out that starting a couple of episodes ago, we sort of changed our production methods slightly. I'd be kind of curious if you've noticed, because it's been a couple episodes, but I actually do want to say behind the scenes, behind Josh was a guy named Darren Young, who for years had been doing kind of the final step of production, kind of contracted him to do that. And he did it patiently for a long time. And we threw him curveballs as well. So I just want to call out that Darren was way behind the scenes, did not get acknowledged. I feel like we should acknowledge him, at least once. Josh is running with how we're figuring out kind of the podcast without Darren. So thanks to Josh, always, Crowhurst. Thanks to Darren, at least the one time, publicly acknowledged. If you enjoy the show, please leave us a review on whatever platform you listen to us on. We do really appreciate having ratings and reviews. Or, just share it with a colleague. Throw a note out on LinkedIn, or tag someone, or send them an email or a text, or make a TikTok about it. No, that would be weird. But pass along the show's existence if you enjoy it. If you want to reach out to us, you can contact us through LinkedIn. You can reach out to any of us on the Measure Slack. You could just send an email to contact@analyticshour.io. So with that, for my co-hosts on this episode, Julie and Val, who only one of them is an outlier in everything she does, and she has shared a couple
Which one?
of... Which one? What do you think? So... I know they join me in saying thanks for listening and keep analyzing.
Thanks for listening. Let's keep the conversation going with your comments, suggestions, and questions on Twitter at @AnalyticsHour, on the web at analyticshour.io, our LinkedIn group, and the Measure Chat Slack group. Music for the podcast by Josh Crowhurst.
So smart guys wanted to fit in, so they made up a term called analytics. Analytics don't work.
Do the analytics say go for it no matter who's going for it? So if you and I were on the field, the analytics say go for it. It's the stupidest, laziest, lamest thing I've ever heard for reasoning in competition.
I don't know, Brett, if you've signed your book for people, but I've had a couple of book
Julie,
signings.
did you hear this story yet?
It's not that funny.
Obviously it is.
I did a book signing at the Columbus Data Analytics Wednesday meetup, and I Googled what do you freaking write? I can't come up with spontaneous stuff.
Yeah.
So I went down the history of book signing and kind of landed on it's just whether it's 4 versus 2, whether they bought it or you're giving it to them, for whoever, little dash, and then it seems like all the best. Period. Sign your name. So I was sitting there signing all the best, signing my name, all the best, somewhere in the middle. That's that funny.
I gotta hear the punchline.
I signed one of them. Best of luck.
No. Good luck.
Good luck.
Good luck.
Okay, Val remembers it better than I do.
Oh my god, just good
And
luck.
it was just a random. So I don't know who it was. I don't know how they interpreted.
Hopefully they didn't compare to the other 35 people.
You need this book. Good luck to you.
Good luck.
What do you know that I don't know?
Dumbass.
Oh my god.
Rock flag and unusual doesn't mean useful.